In this lesson, we're going to solve literal equations. A literal equation is just an equation that has several variables in it. Formulas are a type of literal equation because there are several variables that represent the different values depending on the formula. So some formulas that you may remember are distance equals rate times time, or the area of a rectangle is length times width. Sometimes when we are solving applications, it's beneficial to solve our formula for a certain variable. It just makes the arithmetic a little bit easier to handle. This is because we are working with the variables, which are easier to move around in an equation than actually moving the numbers around. So let's take a look at these. We're going to solve for the indicated variable. So we solve just like we would if we were solving a two-step or multi-step equation. Just kind of pretend that the variables are numbers. I have u is equal to x minus k, and I want to solve for x. So I want to get x isolated. Well, if k was, say, a number like 2, we would add 2 to both sides. So here, we're going to add k to both sides. So u plus k is equal to x. And now my formula is solved for x. In the formula next to it, I have u is equal to x over k. So instead of subtracting by k like I was in the previous example, here I'm dividing by k. Since I'm dividing by k, the opposite is to multiply each side by k. So u times k, or you can leave it as k times u, is equal to x. In the next example, we have 12xk is equal to 4, and I want to get x isolated. So since I'm multiplying by the 12 and I'm multiplying by the k, I can divide each side by 12k. And we could do this all in one step since it's all multiplication here. So the 12 cancels and the k cancels, and I'm left with an x. 4 over 12 is a 1 over 3, and I have the k in the denominator. In this last example, I have 3 is equal to 3k over x, and I want to isolate x. This is a little bit more complicated, but not much because the x is in the denominator. So we have to get the x in the numerator. The way to do that is to multiply both sides by x, and now the x is no longer in the denominator. 3x is equal to 3k, and then all we have to do is divide by 3. So here, x is equal to k. Here are some formulas that will have several steps in order to isolate the variable. So I have 3x plus 2a is equal to negative 3, and I want to get the x isolated. Again, pretend that you're solving a two-step or a multi-step equation. If I want to get this term isolated, I'm going to have to subtract 2a from both sides. Negative 3x is equal to negative 3 minus 2a. Then I divide everything by negative 3. So x is equal to 1 plus, since I have the double negative here, 2/3 a. In the next example, I want to solve for a. Again, I need to get this term isolated first, so I'm going to subtract b from both sides. X minus b is equal to m over a. A is in the denominator. I don't want it to be in the denominator, so I'm going to multiply both sides by a. A times x minus b is equal to m. I need to get rid of the x minus b. Since this is multiplication here, I can just divide by x minus b. So up here I'm going to write my simplified answer. A is equal to m over x minus b. In the next example, I have a is equal to 2 pi r, and I want to get r by itself. I'm just going to rewrite it so it's easier to read. Since, like the example on the previous page, 2 and pi are just numbers that are multiplying r, I can divide 2 pi. Even though pi looks like a variable, it really is just a number, so we could treat it like a number. A over 2 pi is equal to r. And our last example, a is equal to 1/2 bh. We want to solve for h. This problem you may want to take in a couple steps. Instead of dividing by 1/2, because we see we have 1/2 bh, we can make it a little easier by multiplying by 2 instead. 2a is equal to b times h, and then divide both sides by b. So 2a over b is equal to h. You could have divided by the 1/2 and had a over 1/2, but then we have a complex fraction, so you would then have to simplify it to 2a. So it's easier to just multiply by the 2 and not have to do this extra step here. So when we want to solve a literal equation, all we need to do is remember our strategies for solving two-step or multi-step equations. We isolate our variable by moving away the other terms, and then it's usually just a matter of either multiplying or dividing to get that variable to be isolated.